Steam power is one of the most important and key aspects of the Industrial Revolution. The invention of the steam engine created many changes and additions to the technology of the time, including steam power locomotive. Steam locomotives are vehicles that run on rail or track and are powered by steam engine. They were historically used for moving cargo and other material as well as passengers. Although they were popular method of transportation for a large part of the 19th into the 20th century, they were eventually replaced with more modern methods of transportation. The creation of steam locomotives began with the development of the steam engine. The invention of the steam engine dates back into the late 17th century. In 1698, Thomas Avery, an English inventor, patented a device that allowed for the use of steam to pump water from mines. This design was improved upon by English engineer Thomas Newcomen in 1712. Later, further and more significant improvements to the steam engine were made by a Scottish engineer and inventor by the name of James Watt, starting in 1763. It was James Watt's improvement to the steam engine that opened the door to the invention of steam locomotive.
The steam locomotive need water, fuel, usually coal, to run the engine. This is because the engine takes energy stored in coal and convert it to heat. Heat produced is used to move the piston in the steam engine. The fuel of coal is used to run inside the engine, burning inside what is called the firebox. The fire is managed by firemen in the cab who, along with the device, is needed to run the steam locomotive. The firebox sucks air from underneath the train to the fire from starving. The solid fuel sits on the top of it, through which that ash falls down into the ash pan. The firebox allows heat and smoke to escape the chamber through so-called fire tube, running the length of the boiler. The boiler wraps around the firebox and fire tube, thus heating the water inside the boiling point, creating the steam. Inside the steam dome, the steam can find a way out of the boiler toward the piston cylinder. In case the pressure becomes too high and the boiler is exploding, a safety valve pops to relieve pressure. Amount of steam exiting the boiler is controlled using the regular valve. This is effectively the throttle of the steam locomotive.
There are two sets of piston cylinders, one set on each side of the train. Steam engines on steam locomotives are so-called reciprocating piston engines. Each set has one cylinder with a piston connected to the driving rod, which is then connected to the driving wheel. The other cylinder contains the slide valve, which allows steam to enter and use the steam from the piston cylinder. This way, the piston is pushed once from both sides to complete one rotation, creating that reciprocating motion which is then used to rotate the drive wheel. The steam now with its job exits towards the smoke box, where it joins any smoke coming off the firebox to escape up the chimney.
Even though steam locomotive is the invention which pioneered the Industrial Revolution in today's sense, there are a lot of holes that can be filled. For an example, steam locomotive engine lost a lot of energy, especially heat, to the environment. So an immediate improvement is to make a separate condenser. Here, the steam can be cooled without cooling the entire cylinder. There are a lot more inefficiencies involved that reduce the total work done. Many of them are unavoidable, but we can improve them but we can improve the situation by upgrading the piston cylinder. The manufacturing techniques needed to bore accurate and strong piston cylinder were not available in the early days of steam engines. That changed when John Wilkinson invented boring machine, which allow for precise machining of solid iron cylinders, which reduced steam leakage and made the piston cylinder stronger, thus allowing max pressure to rise. Steam locomotive engine does not produce constant torque. They will pulsate and speed and torque during a single cycle. This causes vibration and jerky movement, which can cause inefficiencies. We can reduce this with the use of a flywheel, which store rotational energy with inertia and evens the torque out. The development of steam engine taught us a lot about thermal and mechanical efficiencies, and you all may think steam engines have become obsolete, but nearly all of our large power stations still use steam technology to convert heat energy, whether that from coal, nuclear or solar, to mechanical energy. The technology simply evolved into an even more efficient form with steam turbine.